Good evening. Today we will discuss about hypothesis testing part 2. So, what is hypothesis? How we will test the hypothesis in our statistical analysis? So, let's start it. So, there are two already we discussed. There are two type of hypothesis. One is null hypothesis, and second is alternate hypothesis. And so, there are different variety or different types of hypothesis testings. So that is type of hypothesis we have studied already five different types of hypothesis. Then hypothesis testing is also described here. So first was the definition of a hypothesis. It is the statement about one or more populations that is usually concerned with the parameters of the populations. For example, a hospital administrator may want to test the hypothesis. So this is the hypothesis actually we are going to test. This may be anything, but this is the simple cases. Hospital worker are going to test the hypothesis. So that average length of the stay of the patient is admitted, and the hospital is 5 days. Let's say 5 days. So we have to test this hypothesis that the hospital administrator is the whoever going to admit in hospitals, and the minimum day will be 5 days. That is average day. So how we can to test this? So first definition, their hypotheses are stated with a way that may be evaluated appropriate statistical techniques, and there are two types of hypotheses in testing methods. So we have to observe two things, maybe either null hypothesis, that is H0, or alternative hypothesis HA. So H0 is the hypothesis, so it should be tested. Actually we will be define null the hypothesis first, and we have to test it. Second is alternative hypothesis. If the statement will be available in true if the sample data is rejected this hypothesis. So alternative hypothesis is by default ultimately acceptable when the null hypothesis is rejected. That is called HA. Okay. So there are four conditions maybe. So which are called the types of error. So what are the conditions? First is the condition of null hypothesis is true and the possible action is correct or fail. That is a correct decision. Second is if the null hypothesis is false and the possible reason is the reject of the hypothesis, that is the type 2 error, and the null hypothesis is true but the reason is accepted, it is accepted, that is type 1 error. If the null hypothesis is false and we have also rejected, then it is a correct decision. Whether that means if both are correct, then also correct. If both are wrong, then it is also correct. If any one of them is wrong or false, then it will be error will be occur. So type 1 and type 2, there are two types of error. So where A0 or null hypothesis is rejected, we conclude that alternative hypothesis is accepted. That means true. If the A0 is rejected, then alternate hypothesis are true. Or if alternate hypothesis is accepted, then A0 is false. So this is the two conditions obviously arises in the hypothesis testing. So hypothesis about of a mean population, how we'll define. So we have the following steps. First, prepare a data. So what are the variable? Determine the sample size, that is mean, population, standard deviations. All these things we have to calculate because it is unknown, because lots of data are there. In order to define all this data, you have to assume something. So second point is assumptions. So we have two cases. Case one, that is population is normally appropriately distributed between the variance, that is n should be small or large, that is depending on your criteria. Case 2 is population is not normal with this unknown or known variable because the sample is very large, that is greater than 30. So if the sample size is very large, the sample is greater than 30, then population is not normal because all data cannot fit to the normal population. The third point is hypothesis assumption of this hypothesis, then put the hypothesis. So there are three different cases maybe. One is null hypothesis, which is first you have to put both, that is mu equal to mu 0. That means the mean is, or calculated mean or assumed mean, equal to the sample mean, that is mu 0. On the other cases, that is alternate hypothesis, that is mu does not equal to mu 0, that means the assumed mean is not equal to the given mean or calculated mean. So that is the condition. We want to test this population mean is different than 50. Let's examine in the previous examples. For the hospital cases it is 50, then it is if not equal to 50 or other than 50. So case 2 is when the hypothesis is equal to, null hypothesis equal to the assumed mean, minimum equal to the hypothesis, that is null hypothesis, and the alternative hypothesis having two cases, either the calculated mean is more than the assumed mean or less than the assumed mean. So that is the two conditions. So we want to test whether the population mean is greater than 50 or less than 50. So this is two extra cases, but this is same condition arises. So there are two different form of this hypothesis testing in these cases. So see here, testing a hypothesis for mu, that means sample size is large. So what happened? This population normal is not normal, or it is small, less than 30, then population size is normal. If the large population size, then we will treat these questions differently, and for the small population size, we will treat these questions differently. So sigma is in one case is known, or second case sigma is not known. That means the sigma is the standard deviations, and there are different methods to calculate the testing hypothesis, because if sigma is not known, not given, we have to first find out that value and put the formula for the testing. Even sigma is given, then it is different cases where we can put the formula for the testing of hypothesis. That is, for the population is not more normal, then also two cases there, and population is normal, then there are also two cases. That is z equal to sigma mean minus mu 0 by sigma by n, where n is the number of samples. Both cases here, see, the hypothesis, if in all hypothesis as 0, mu equal to mu 0, and it is assumed is not equal to calculated mean, then we have neglected these two tail parts of this normal curve. And if other two cases, different cases are, if the it is calculated mean is less than equal, less than assumed mean, that means right side we are neglecting, and it is more than assumed mean, then it is left side we are neglecting. So the critical value are lies between z alpha by 2 to z alpha minus 2. So z is the crucial value acceptance of this hypothesis, whether it is holds good or not, we have to just calculate with this formula. And by seeing the sign, that is either plus sign or minus sign, if it is sign is plus sign, then it may be in the right side a tail test, and it's in the left side minus, then it is left side tail test. So same cases here also, that is t test or calculating the t value of t, that is x bar equal to mu 0 by sigma n minus 1. So here also this is the second formula, because the z and t are slightly different, but in different cases as previously seen, there are four cases. So for each case there are different statistical tests for calculating our hypothesis true or false. So if t is greater than t alpha by 2, that is it is two side test, and t is less than 1 by alpha, that is minus t alpha, the negative sign, then it is one side tail test, and it is also greater than alpha, then it is also negatively side and one side tail test. So this is the different cases. Let's see what are the cases. So the p value or decision making is the main important point. What is the p value? P value is the smallest value of the alpha for which it can reject the hypothesis. This means the value where up to we can accept or where it can maybe reject. These are the important terms where it can be, by seeing this value we have made some conclusion whether our decision is right or decision is wrong, that is depending on this p value. Suppose the the z value, that is x minus x bar by mu 0 is sigma by n, is the computed value, that is for the statistic. So the following table is displayed the p value, and how use the p value. Let's see it try to understand the alternative hypothesis, that is mu not equal to mu 0 and greater than or less than equal to mu 0, that is the alternative hypothesis. So if p value is 2 into that z value, so it is under this zc mod of zc, then it is also significance is alpha, then we are rejecting the null hypothesis is the p value is greater than the alpha. So this is the examples. Let's say for previous examples, let's say zc equal to find that 2.02, and the alternative hypothesis h0 is mu greater than 70. So the p value for calculated things is, so you have to calculate 1 minus this z 3.20 value, so it is 0.271, and the significance level was 0.05. So here p value is less than the sigma, so the alpha, because the we have to reject this hypothesis, means whatever we are considering, that we have to fail it or we have to reject these things. So it is very difficult to decide the significance levels and the acceptance or rejection regions of this hypothesis. So lastly, we have, by seeing this significance level or acceptance or rejection region, we have to decide whether our hypothesis is reject or hypothesis alternative hypothesis acceptance of this alternative hypothesis. So however, we do not reject H0, that means H0 is true. Either you have to reject or you have to accept. If null hypothesis is reject, then alternative hypothesis is acceptance. You have to hold by default accept, or if alternative hypothesis is accepting, then obviously it is null hypothesis rejecting. So an alternative decision rule using the p value definition, that is the important thing, because p value is defined the smallest value of alpha or the significance level which null hypothesis can be rejected. So whatever be the remember the normal curve, the p value is decided at a value which is the most important factors for this rejection acceptance region and rejection regions, which is derived by the null hypothesis. So this p value is less than or equal to alpha, so we have to reject the null hypothesis, and secondly the p value is greater than alpha, so we do not reject this null hypothesis. So this is the main condition, or we have to take the alternative decisions according to our data. This is one examples. Let's say researchers interested in the small age of certain populations, a random sample of 10 individuals drawn from the population of a own interest and has a mean of 27. So assume that populations is expectedly normally distributed with variance 20. Just try to calculate it, whether you have to find out or not. Then I will be show you how to calculate. Just try yourself. I give you 10 minutes. So do yourself and take the significance value level is 0.05 and the p value is 0.0340. So make a suitable null hypothesis and define it. After that, make a decision on the basis of your hypothesis and the acceptance value. So are able to doing? Okay. Okay, what is your answer? Let's see in the solution here. Here the variable is let's say n equal to 10 and the mean of the x bar equal to 27 of the population and alpha sigma square is 20, that is the variance, and alpha is 0.05, that is the significance level. So let's assumptions, you have to do assumptions. Population is approximately normal distributed because it is now n is 10 which is less than 30. So for the hypothesis mu equal to 30, let's say you assume that null hypothesis there is no other than difference the calculated mean and the assumed mean, so both are equal, and obviously the alternate hypothesis is not equal to 30. So that is the second point. So whatever may be the reason, let's see. So use your t-test or t-statistics. So draw a normal curve and the value of z is minus 2.12. So decision rule is the hypothesis is z not equal to 30, the alternating decision. Hence we reject the hypothesis z equal to minus point, it is see the tail area where the value is lies within the rejection region. So this is the value z of 0.975 is 1.67. We have to refer the table for D that is given in your questions, and this may be the answer for that. So let's do this calculation. Okay. So what about the decision? We have to reject this null hypothesis since it is 2.12 and which is the in bit lies within the rejection region. So we cannot conclude that the mu, that is mean, is not equal to 30. Hence, obviously using the p value we can calculate that we have to reject the null hypothesis, which means the value is not equal to 30. That means the mean is not equal to 30. So we have to alternate these things to reject. We have to reject this hypothesis. That means we by default accept this alternate hypothesis. This is our main rejection for this hypothesis testing. See another example. Here we can also use the researchers to ask the conclude whether it is greater than 30 or not. So see the previous data, same data, but here the assumptions here you can see it is also same like mu equal to 30 null hypothesis and mu greater than 30 for the alternate hypothesis. So use the same t statistic, z is bar equal to mu 0, max bar z equal to x bar minus mu by sigma by root n, that is 27 minus 30 by 20 by 10 to minus 2.12. How we calculate this? which is lies in between the z equal to 1 and alpha, and by seeing the table of D we can find out the z is 1.645. So here also that is less than 2.12, so we have to reject this null hypothesis. So we can conclude the population mean is smaller than 30. That means it is not equal to 30 or not greater than 30, it is smaller than 30. Okay, so let's discuss another one. If you have no questions. So another example is for African American men, the men so split blood pressure was 146 and with standard deviation of 27. So we wish to know if the basis of this data, what is the basis of the data? So what to conclude, the mean of the blood pressure of population of the African American is greater than 140, that is in alpha or the acceptance regions of that is 0.01. So 0.01 is very less. So let's decide whether it is working or not. Our the hypothesis testing. So given blood pressure is 146, but it is greater than 140. So let's assume 140 is the standard, and it is greater than 140, that is 146. So let's do whether it is a common statement for all, or either it is not acceptable or it can be rejected. So let's do the things. So here assume n equal to 157. It is greater than 30. So it is a non-normal graph of data, which mu equal to 146. That is the number the blood pressures, s equal to 27 and alpha region equal to 0.01. So here assumption is population is not normal because it is greater than 30. Sigma square is also not known. So here assume your hypothesis, that is mu equal to 140, and second is mu is greater than 140 because it is given as 146. So for utilize Z statistics, calculate this one value. So we have found it is 2.78. Just put the value, nothing do it, nothing very big task. So let's decide by giving the value from the table. We have found that it is 2.33. Compare the value, that is for calculation it is 2.78 and the tabulator value is 2.33. Here the tabulator value is higher than the calculator value, that is 2.33 is greater than 2.78. So in this case we have to reject this hypothesis because it is more. So the average normal blood pressure of the population is greater than 140. That is the main decision, because 140 we have to consider it is 140 in null hypothesis. In null hypothesis it is 140. So this hypothesis is rejected because the calculated value is greater than if this null hypothesis is rejected. This is the main conditions. If it is smaller, then it should be accepted. So it is accept the second hypothesis. This is the main thing. So average blood pressure is greater than 140, not equal to 140. So we have to test like this every type of hypothesis or a problem. We have to test this hypothesis. So make a decision after testing hypothesis. You have to make a decision. Okay. Okay. Let's do one more exercise. So let's discuss these things. Exclaver performed the study of validated translated version of the Western trio, and the McMaster University, that is questionnaire is based on this data. The Spanish speaking patient with up to a hip and knee osteoarthritis, for example, 76 women classified for the server is Spain. So this mean function score was 70.7 and the standard deviation is 14.6. So you wish to know if we conclude that the mean function score for a population of smaller women subject to hip pain is less than 75 for a significance level of the alpha equal to 0.01. So here it is given that the women are classified into two categories, either it is greater than 70 or less than 70 or it is 75. So for the uses of significance level of 0.01, so for solution, you have to first extract the data. After that, you have to make assumptions and the hypothesis and use the test statistics. Let's try it. So are you able to do this? Okay. Make a decision, then decision. So let's do another hypothesis testing of your own. Okay, so purpose study was to investigate the overall status of a group patient diagnosed with thalassemia, that is measured, which is outcome of this delayed thing. And in a sample of 18 patient, mean of 10.3 started the standard deviation of 7.3, and the index is greater than 9. So here also you have to calculate the significance level for 0.1. So this acceptance or rejection region is here greater than other, because that is not 0.01, it is 0.1. So here the things are given. What are given? Patient of sample number of patient is 18, and standard deviation, that is 7.3, and the greater than index, that is 9, means the value which is 9. So that put a hypothesis, and then assumptions, then statistics, then decide, then all the things. So you have to do like this. Every statistical hypothesis we have to test like this. So uh, what are the steps? Let's summarize again. The data, we have to write down all the data one by one. Then we have to put assumptions, either it is case 1 or case 2, that is normally or distributed or not normally distributed. If this sample is large, then it is not normally distributed, but it is very small, then it is normally distributed. So according to these assumptions, we have to make the hypothesis. First is called null hypothesis, that is H0, which is saying that there is no significant difference between the given mean and the assumed mean. So that's why it is equal. No significant difference, that means it is equal. So what is the alternative hypothesis? It is obviously it is a having not same. That is either maybe two cases, whether it is greater than or it may be less than. So total there is three cases, that is mu 0 equal to mu 0, mu equal to mu 0, mu equal to greater than mu 0, and mu equal to less than mu 0. According to you, decide which cases we have to applicable. So for that, both cases, whether it is either maybe normal or not normal, sigma that is given or not given, we have to use according to your statistic, whether it is use the Z statistic or you have to use as sorry T statistics test. So this is for example, if it is two side, rejection side is two side, that is normal curve, that is one side tail test, and it is positive side, then it is called positive L test, negative side is a negative Z test. So like that you have to test these things, whether it be either Z test or it is similar to T test. So according to seeing the value of P, we have to calculate this thing, that is whether it is positively distributed, negatively distributed, or maybe some kind of things. So let's discuss again in previous thing. What is it? That is the different types of hypothesis. What are the different types of hypothesis? See, these are the different types of hypothesis. Various types, hypothesis types. First hypothesis type is, that is called descriptive hypothesis. See, this is called descriptive hypothesis. For example, the level of primary education in the government schools, Uttar Pradesh, is not satisfactory. So the persons of the student attending regular classes are decreasing in higher education. So this may be the reason for the thing. So that is the description for the particular statement. So that's why it is called a descriptive hypothesis. Before going to the research, actually doing the research, you have to propose these things for or assumption, that is called assumption or proposed data. So then again, according to our this proposed value, just calculate the whether it is true or false. So according to the different test, we have to calculate whether it is true or false. Second is relational hypothesis. We have to find out the relations between two or more variables. That is, it whether the frequency is same or not. That is, for example, families with low income spend greater portions in the consumer goods. Means the family which are income is very low, they spend more in the consumptions of goods, daily goods, rather than they are investing the money in different sectors, because they are very poor, and whatever their money earn, they are just spend these things for their daily needs. So this is the relation between the daily needs and the incomes. Whatever may be your income, you will be spent the money according to you, according to the income of the money, because the it is directly proportional. It is related to your spending is relation directly related to your income. Third is hypothesis is proposed of making comparison, that is comparative hypothesis. You have to compare between two data or two samples. Another type of hypothesis, which is the particular characteristics of one factor which is determined with the other characteristics. So the change in one variable, that is dependent variable, is the main source of interchange the other variables. And this kind of hypothesis is called causal hypothesis and causal effect hypothesis. Because one variable is dependent fully with the cause of the other variable. So next is the difference between the two or more statistical value based on the potential data. So it is called a statistical hypothesis. So for example, there is no significant difference between the mean of two samples, or because this type of hypothesis is mostly used in our statistical problem solving, like in previously we have solved this value. How this is called as statistical hypothesis. So sometimes and researchers may not sure about this phenomena. So before going to make a decision or making questions, again we have to change the variable or change the hypothesis time to time. So this type of hypotheses are called as working hypothesis, because the hypothesis is not fixed and it can be changed according to its time and value. Okay, so let's see the characteristics of hypothesis. Whether it is good or bad, we have to describe some characteristics. A good hypothesis is always be follow this following characteristics, like it should be empirically testable and it should be logically defensible. Hypothesis should be closest to the things observable and should take enables a researcher at this correct decision, and it should be consequentially clear to explain concept of having to no for ambiguity. So hypothesis must be specific but not in general term. So this is the general criteria for setting a good hypothesis. So there are different procedure for hypothesis testing. So let's discuss one by one. The procedure, uh, completions or corrections of the hypothesis, and the test procedure should be followed by the setting up a null hypothesis and the alternative hypothesis. We are already discussed. Just read this article again. Here it is given so many examples. Let's discuss one by one. So, setting up a null hypothesis, that is no effect between the campaign process and awareness. This is one example. Second is no extra classes will be needed because no benefit will be given the students. And also the drug has not effective in the curing some diseases. So here null hypothesis, that means you have to set it negative sentence or in negative voice, because the name is null hypothesis. That means no significant difference, not effective. So use a negative words in this hypothesis. So majority of the chance of this null hypothesis is going to be rejected, because is a significance level we are testing the hypothesis is very less. So we have to think like this. So second part is alternative hypothesis. So opposite whatever you are thinking or assuming in null hypothesis. So the positiveness might means the drug is effective. There should be need of extra coaching classes, and there should be a difference between the two variables. Whatever these things we are studying in the previous slides, these are all called as alternative hypothesis. If one hypothesis is rejected, and another is obviously accepted. So that's why again here also there are two types of error: type 1, type 2 errors, and this error is are very significant for your test. Then setting this significance level, we have studied whether it is one tail or two tail, then setting a criteria, then computations, making decision, all are related to the setting of hypothesis. Just read that thing. And also you have to find this thing, four things, that is acceptance of H01 is a type 1 error, what is type 2 error, and both are decision is wrong, that is also correct, and both are correct, then you also be correct. So these are the four things mainly studied in our statistical hypothesis testings and the procedures. So be careful on it, and in exam all these things are going to be in your class. Whatever your studies, these are in your exam directly. Like describe what are the type 1, type 2 error, what is hypothesis testing procedure, and for given value statistical sigma, statistical value, how to purpose significance level, testing the hypothesis. All things these are very crucial for this chapter. So read carefully. And most of the significance level are set up either it is 0.01 or 0.025, and maximum that is 1 point. Because in this graph, that is called normal curve, most two side are 50-50% are these values are acceptable, and for x minus 3 sigma, x minus 2 sigma, or x minus sigma, we are treated all the x minus plus minus 3 sigma is the highest value, and it is up to 99.5, means up to 99.5% all data are within that normal curve, but the 0.5% which is the lies to the last two sides of the normal curve, this is that we have to call as rejection region. So most of this null hypothesis are within that rejection region, because it is tested within that 5% of significance level. So before setting up the hypothesis, you have to set the hypothesis like that. It can be lies within the reaction region, that is 0.025 each side. So that is the mainly. And after that you have to set a suitable criteria whether it is applicable in Z test or T test. Then you have to set calculate your data by whether it is either is a normal curve or not, and the sample size is greater than 30 or not. So seeing all these things, we have to decide to test this hypothesis. So that is the main thing we are already same thing we are studied here. Then go through the slides carefully and make a note about it. So if you have any doubt, we will discuss in next class. So for today, here it is. Just summarize again. The hypothesis is the parameters we have to test it for the for populations, and there are definition of different statistical hypotheses, whether it is either null hypothesis or alternate hypothesis. So there are two types of errors, either it is type 1 error, type 2 error, or the type of decision making different kinds, and the characteristics of the good hypothesis, types of hypothesis. All these things are very crucial to for the step chapter, and these are the steps for testing hypothesis. We have to find out the data which is given. The data is nothing but the sample size and the mean, sample mean, population standard deviations, and the sample standard deviation. So there are four things are there: sample mean, sample standard deviation, population mean, population standard deviation. Four categories are given. So for each category you have to put either test whether it is a small or a large, because samples are small and populations are large. So if it is less than 30, it is called a sample, and more than 30, it is called as population, or it is tested for the whole universe. So it is not, but the sample size is normal, and but the population size is not normal. So depending on this different hypothesis procedure, then assume the null hypothesis and alternate hypothesis for your calculations. Okay. So these are these some examples we already discussed. Go through it. Okay. Good night.